Time marches along, and this is our punctibyte for the week of February 18th. I'm going to kick things off with a little conversation about antibiotic resistance. This is a perfect time to talk about it as it's pretty hot in the press, but also because this is the week that we'll be covering antibiotics in Lab 8. So during Lab 8, we'll want to talk quite a bit about selective pressure and some of the misunderstandings that arise with antibiotic resistance. I wanted to share a quick article with you just because it's so trendy. It was today on the Twitter feed from the CDC's, basically talking about the increase in resistant bacteria, but more expressly in a particular type of carbapenem resistance in Enterobacteriaceae. So this is a type this antibiotic is actually a type of beta-lactam antibiotic, and the unique kind of resistance is due to a metallo-beta-lactamase. So remember, beta-lactamase is being the enzymes that cleave that beta-lactam ring, inactivating it. So this is just a type of resistance that we're seeing on the upswing in the genera within the family Enterobacteriaceae. So always an issue and always a trendy issue, and certainly something that you can intertwine into your Lab 8 lecture if you happen to be giving that particular lecture. So let's pull up our schedule so that everybody knows where we're headed with that. We'll be looking at, for most of you, Lab 8 in the early week, and then Lab 9 later in the week, and both of those dealing with antimicrobials. Lab 8 more with UV, antibiotics, and antibiotic resistance, selective pressure. Lab 9, or a little more with antiseptics and disinfectants in that one. Erin and Tara and Kyle, you guys are up for open lab this week, so I'll see you on Friday, or I'll see somebody who's substituting for you on that day. Fantastic. Shouldn't be anything out of the ordinary this week as far as scheduling, but a big reminder that Lab 8 is a really jam-packed full lab. So I'm going to pull that up in terms of the TA guidelines, and we're going to talk just a little more about it. I know I gave it pretty good justice in the last punctibyte, but I want to remind you that we'll want to assign each of the groups, or each of the 3 lab benches, to different activities to begin. They will all do everything eventually, but if we can split them up to start with, there's not as much crowding at the UV light station and the Kirby Bauer station. The UV light station is an important one for one of the TAs to man, because at that station they'll be tempted to want to reach in without turning the light off, exposing their hands to the UV light or other appendages possibly. So we want to make sure to keep that to a minimum risk. And I think if somebody can just sort of hover around that station, particularly if you have 3 TAs, that really helps a lot. Also for this lab, I have actually tried to set everything up mostly on Friday as far as getting the signage out and whatnot. So it should hopefully be easier for those of you who are going on Monday. So for Jacob and Richard, I hope that will be of help to both of you. Also, a reminder that we would want to remind the students to bring the antiseptics and disinfectants for the next lab. So if you have a moment to just announce that they should bring something from home. We do have antiseptics and disinfectants that we will provide in lab, but if the students can bring something fun, and you never know, they may have something that they've picked up at work, an odd or unusual antiseptic or disinfectant, or maybe they are like full of piercings and they've got something cool that they use to help with their piercings or tattoos or whatever it might be that might be antiseptics. So definitely remind them about that and give them that option of bringing in something of their own that might be really fun for us to look at and test. Also, while you're doing the Lab 8 lecture, either I can do this or whoever, one of the other TAs, to show them how those little antibiotic disc dispensers work. They're kind of like little Pez dispensers, and you can flame the forceps, dip in ethanol and flame. Don't get them too hot because the heat will denature the antibiotic. So then just press out with the forceps from one side and pull from the other side. Great video of this on Virtual Edge. So you can ask the students, if everybody has watched it on Virtual Edge, you don't have to demo it again. But in fact, most of the time, there's at least a couple people who need that demo. So that can be done actually during the lecture, and we can set up the doc cam for that in order to better show the students how that will work. All right, let's take a look at Lab 9 TA guidelines and just make a couple of quick notes on those. Lab 9 is a really straightforward lab. it's a bit of a break in terms of the lecture. So for those of you giving that lecture, it's pretty straightforward and pretty fun, and you'll definitely enjoy talking about antiseptics and disinfectants. And maybe if you haven't already, talk to me about using the autoclave and how the autoclave works. That would be a great thing to do. The other thing that we'll be doing during Lab 9 is a hand washing experiment, and we'll want to split the group into a couple of groups. So essentially, usually we'll split them into 2 groups. It depends on how many things we have we can test. So we can split them into 2 or 3 groups. We can have one group that really just washes their hands using like good old-fashioned hand soap. The other thing that we can do is we've got some hand sanitizers, so we can have part of the groups do like one type of hand sanitizer or another. So it doesn't matter how we do those groups, we just have to be really organized in telling the students what we want them to do. And if we want them to wash for a given amount of time with mechanical action, then we should make sure that we make that clear, and for how long we want them to scrub and all of that. If you want to split into more groups, if you've got some ideas for having one group do good mechanical action and the other group just quickly wash, that'd be another thing that we could vary and test as well. So Lab 9 should be fairly straightforward and fairly fun, which is good because in Lab 10 we have a heck of a lot to do. So I'm going to go on to this only for T and Elia, who will be doing Lab 10 on Thursday. So bear in mind that this is one you have to be super organized for. That is, you need to start Lab 10 right away, right when you walk into the lab. So that means that you're going to have to get the students doing the first few steps where they pick up their competent cells, they get their competent cells aliquoted into one tube that has a plasmid and one that does not, which means they'll have to pipette about 10 microliters of the plasmid into the tube with. So it takes a little bit of labeling, a little bit of time, and those few steps have to be done right away up through the 10-minute incubation or the 20-minute incubation on ice. Now, I believe that's step 6 in the lab manual, so we'll want to work them through that step at the very, very beginning of the hour. After that, then they can go and pick up their stuff from the prior lab, and they can go ahead and interpret results while they're waiting for everyone to get on ice. But as soon as the last group is on ice, then we'll start the timer. So whatever that last group is, they can time everybody's 20 minutes. So each group won't be on their own 20 minutes, but every group will be timed according to the last group to get on ice. That then gives us a chance to give the lecture. So whoever is giving the lecture will launch into the first 20 minutes of the lecture at that point. These guidelines give a little bit of background on the lecture. However, they're not fully extensive. So if you have any questions on this lecture, if you happen to be giving it, please let me know. Also, if you don't have much background in gene expression, or you're having trouble understanding plasmids and regulation of genes, then maybe this is a better one to have me do, or to ask to have me do, or Jacob or Richard do for this one. They will also start Lab 11, or they will do Lab 11, which starts Lab 12, the bacteriophage isolation. So this can be done during the second 30-minute incubation, as well as other things that they didn't finish up that can be completed with results interpretation and whatnot. I usually like to take a few minutes during that second 30 minutes as well to talk about the results from the hand washing experiment. I think it's really important to talk to students about these results, because if we don't talk to them about them, they usually go home with these messages that are definitely not on the mark. For example, I'm never going to wash my hands again, because they see more growth perhaps on their treated side than they did on their untreated side. So it's important to explain why that might happen. How washing can mobilize bacteria. If your hands are still moist, that can lead to what looks like a lot more growth. It's also important to help them recognize the difference between normal flora and non-normal flora, and how our goal is actually to get rid of non-normal flora. I think it's also then important to talk about how if they see hand sanitizers where there's growth on the untreated side and no growth on the treated side, why that might be not, a sort of dubious improvement, because in fact we've killed off normal flora as well, opening up a window of opportunity for pathogens to be able to colonize and invade. So it's very important to send them away with the right take-home messages from that particular lab. I think that summarizes everything going into this week, and I hope that everybody had like a super fantastic weekend. With the ski team, we had our home race, and it was harrowing but amazing, and I'm really relieved because our athletes are starting to peak, and it's always so awesome to see them in that state. Everybody's got high energy and they're just feeling like full of spite, so it's just fun. I'll talk to you all soon, and I can't wait to see you on Monday or Tuesday.